Assalamualaikum and very good day. My name is Anis Fadila Wahid and I am a final year student of Bachelor Science Maths Chemistry with Management. My final year project is about synthesis and characterization of bilytic sheet base and their copper to and nickel to complexes as catalysts in oxidation reaction. And I am supervised by Dr. Amelina Muhammad Tajuddin. I will begin my presentation with the backgrounds of the study. So sheet base is formed when primary amine and the carbonic compounds are condensed with the removals of water. In my study, the carbon that I use is ketone, which is 2-hydroxy-4-methoxy-acetylphenone. So the problems of my study would be the influence of ligand structure on the metal complexes. Next is whether the metal complexes can act as catalysts in the chosen oxidation reaction. And the last one is the problem in limited research of sheet-based ligand from ketone and amino group. The ones that I found a lot is a sheet-based and metal complexes from aldehyde and amino group. So this is the significance of my study, which focuses on whether the metal complexes of copper-2 and nickel-2 can react as catalysts in oxidation reaction, which can contribute to the industry involved with oxidation reaction. So this is the objective of my study. Moving to the literature review, this is the metal complexes of sheet base reported by Karakaya 2016. Here I attached the result of IR spectra, UV base, magnetic susceptibility and also molar conductivity from the journal. So overall, the metal complexes of copper-2 and also nickel-2 obtained by Karakaya 2016 were successful as there was a presence of new peaks belongs to the metal oxygen and also metal nitrogen fusion group. So the complexes were reported as non-electrolytic and having octahedral geometry based on the spectra and also magnetic studies. This is the oxidation reactions of catalysts, which was reported by Anthony 2013, which involve oxidizing cyclohexene to cyclohexanol and cyclohexanone. So the finding of the activities discover that copper complexes show a better catalytic ability than nickel complexes. Now moving on to the methodology. So this is the procedure to synthesize both ligands L1 and also L2, which I adopt the method from Robertson and Nelson 2023. This is the proper structure of L1 and L2, having oxygen and also nitrogen as donor atom. This is the procedure to synthesize metal complexes of L1 and also L2. So the only difference is the additions of triethylamine in metal complexes of L2, which was washed with diethyl after washed with cool ethanol. And this is the proper structure of metal complexes L1 and L2 in 1:2 ratio. So this is the method for catalytic activity, which I use flame ionization detection to analyze each sample. And this would be the last slide for methodology, which is the list of instrumentation that I use to characterize ligand and also their metal complexes. So moving to the result and discussion, the compound I obtained in solid for L1 and all the metal complexes except for L2, which I obtained in cloudy liquid form. Based on the data in the table, it can be concluded that the compounds I obtained are not pure, as there are differences in the values of multipoint and also CH and S with more than 3 values. So all the complexes exhibit non-electrolytic behavior based on the low value of molar conductivity. This is the FTIR spectrum. So overall, the figure shows functional group of suitable N of L1, which shift to the higher wave number in the metal complexes, plus metal to nitrogen and metal to oxygen are responsible for the appearance of new weak peak in the spectra of these complexes. Similar case for L2, but the suitable N is shift to the lower wave number compared to the L1, which shift to the higher wave number. So for NMR analysis, only L1 was analyzed using NMR spectroscopy due to the L2 being obtained in liquid form and all the complexes were paramagnetic. So for proton NMR, spectrum of L1 shows a doublet peak at 7.28 and 7.09 ppm, which corresponding to the phenolic OH group. So there is also a group of multiplet and also singlet peak observed in spectrum, which contribute to the aromatic proton and also methoxy group respectively. So for carbon NMR of L1, it shows a chemical shift range from 105 to 164 ppm, which is assigned to the aromatic ring carbons, and the chemical shift for imine carbon was discovered at 165.62 ppm. There is also addition peak observed in the proton and also carbon spectrum, which contribute to the presence of starting material in the compound. For UV spectra, I've been comparing my data with Argon 2020. The position for electronic transition between 300 to 420 is presented to pi to pi star and also n to pi star transition, which refer to the aromatic ring and also non-bonding electrons of the nitrogen atom. However, the peak observed might not be exact of benzene and also imine transition due to the cutoff at 265 nanometer with the MSO as the solvent at the concentrations of 1 multiplied by 10 power of -5 molar. So the magnetic moment susceptibility of metal complexes computed using the Goy method, and the magnetic moment obtained is close to the theoretical value, which indicates that copper 2 and also nickel 2 have a tetrahedral geometry. And there is no result for nickel complexes of L1 as there are not enough amount to conduct the magnetic susceptibility. So the catalytic activity of metal complexes was unable to be determined as there was only a peak belonging to acetyl material observed in every sample. This might be due to the mistake in preparing the samples, or the method might not be suitable. In conclusion, the bidentate shift-based ligand and their complexes were successfully synthesized and having a 1:2 ratio. The spectra and also magnetic studies shows the proposed geometry for copper 2 and also nickel 2 having a tetrahedral geometry. And as for the catalytic activities of metal complexes, oxidation reaction was unsuccessful. So there are a few recommendations based on my studies, and I think the most important one is to identify the chemical materials for the reactions and ensure that they are in a good condition by refer to the safety data sheet. This progression is based on my previous experience where I spent like 3 weeks synthesizing reactions only to discover that my starting material had already decomposed, which put me in a situation where I need to start all over again. So for the next 5 slides is the reference that I referred to in order to complete my thesis with a total of 29 references. With that, thank you.